Alright, so in this masterclass, we are going to be looking at the topic quadratics, and under this topic, we will be touching on the concepts completing the square, the quadratic curve, quadratic inequalities, nature of roots, that's the discriminant, disguised or hidden quadratic equations, and simultaneous quadratic equations. So as we are getting started, let's look at the concept of completing the square. Now, the quadratic expression ax squared plus bx plus c can be expressed in the form a of x plus p squared plus q, and this can be done by a method that we call completing the square. So, when completing the square, let's say you have a quadratic expression x squared plus bx plus c. To complete the square, you are going to open up your bracket. Then for the first term inside the bracket, you are going to put the square root of x squared, which is x. Then you are going to add half of the coefficient of x. Here, the coefficient of x is b, so half of that is half b, or b over 2. So we're going to put b over 2 here, then we close bracket, then squared. After that, you subtract the b over 2 squared, and then you add the c, which is the constant that was already there in the original expression. So this is the procedure for completing the square. Let's have an example. Here we have a question which says, express x squared minus 2x minus 15 in the form x plus a squared plus b. So in this case, we have been given x squared minus 2x minus 15. And to complete the square, I'll open up my bracket, then I'll put the square root of x squared, which is x. Then I consider the coefficient of x, which is minus 2, and half of that is minus 1. Close bracket, then squared. And I'll subtract that minus 1 squared. And this is going to be plus c, which is the minus 15 that was already there. So this will give us x minus 1 squared, and this will be minus 1 and minus 15, which therefore gives us x minus 1 squared minus 16, and this here is the answer. Let's move on to another one. Here it says, express x squared plus 6x plus 5 in the form x plus a squared plus b, where a and b are constants. So again here, from the x squared plus 6x plus 5 that we've been given, I'll open up my bracket, then I'll put x here. Then the coefficient of x is 6 and half of that is 3. So we put the 3 here, close bracket squared, then subtract the 3 squared. And this is going to be plus 5. So here we'll be getting x plus 3 squared, and that's minus 9 plus 5. And eventually this is going to be x plus 3 squared, and minus 9 plus 5 is minus 4. So this here will be the answer. Let's have one more. Here it says, express x squared minus 4x plus 7 in the form x plus a squared plus b. So here we're saying for the x squared minus 4x plus 7 that we have been given, this is the same as opening up the bracket, that will be x plus half the coefficient of x, which is minus 4, so that will be minus 2, close bracket squared, and it's going to be minus the minus 2 squared, and it's plus 7, which then will give us x minus 2 squared minus 4 plus 7, and eventually we'll be having x minus 2 squared, and minus 4 plus 7 is 3, so it's plus 3. And that's how we complete the square for this particular one. Now, if you look at the questions we have done so far, you can see that they all have the coefficient of x squared being 1. So the question here is, how will we complete the square when the coefficient of x squared is not equal to 1? So that's when we come to questions which involve us completing the square and expressing the result in the form a of x plus b squared plus c, where a and b are constants and a is not equal to 1. Alright, so we have some examples. Let's start with this one here, where it says express 2x squared minus 12x plus 7 in the form a of x plus b squared plus c, where a, b, and c are constants. Alright, so for this particular one, we have 2x squared minus 12x plus 7, and in order for us to complete the square, we are going to factor out 2, okay, for the first two terms. So if I factor out 2, I'll be having x squared minus 6x, alright, and it's plus 7, which is on the outside here, alright, and here I am going to complete the square for x squared minus 6x, which I know will give me, opening my bracket, that will be x minus half of the coefficient of x, 3, close bracket, squared, and we subtract the minus 3 squared, alright, and close bracket, and there's a plus 7 on the outside. So basically we'll be having 2, and that's 2 of x minus 3 squared, and here that's minus 9, close bracket, plus 7. I'll now multiply the 2 into the square bracket, so we'll be having 2 of x minus 3, close bracket, squared, and it's minus 18, and it's plus the 7 that's outside. So eventually we'll be having 2 of x minus 3, close bracket, squared, and minus 18 plus 7 is minus 11. So we have this now as our answer right here. Let's move on to the next one. Another example says express 3x squared minus 6x plus 2 in the form a of x plus b squared plus c, where a, b, and c are constants. Alright, so we're saying for 3x squared minus 6x plus 2, this is the same as, and I'll factor out 3 for the first two terms, so 3, and we have x squared minus 2x inside here, and the plus 2, which is outside. So here, if we complete the square on x squared minus 2x, we'll be having x here minus half of the coefficient of x, okay, which is 1, close bracket, squared, and we subtract the minus 1 squared, and it's plus 2. The 2 is outside, so I put it here, so it's plus 2 like this. Alright, so that's going to be 3 of x minus 1 squared, and here we'll be having minus 1, and multiplying that by 3, it will be minus 3, and it's minus 3 plus 2. So that's 3 of x minus 1 squared, and minus 3 plus 2 is minus 1, and this here becomes the answer. So that's how we would do it for these type of questions. Next up, we want to look at a particular situation where the coefficient of x squared is negative. For such situations, you might be required to express your complete square expression in the form a minus b of x plus c squared. And this usually happens when the coefficient of x squared is less than 0. So we can have an example like this question here, which says express 7 minus x squared minus 6x in the form a minus x plus b squared, where a and b are constants. Alright, so in this particular case, we are going to start by rearranging this expression. So the 7 minus x squared minus 6x can be written as minus x squared minus 6x plus 7. So here, I'm going to focus on the first two terms for completing the square, and I'm going to factor out minus 1, which means I'll be having inside the bracket x squared plus 6x. But we already have the 7 outside, so it's good. Now, this is going to be minus, and I'm now completing the square, the x squared plus 6x. So I open up my bracket, then x here plus the coefficient, like half the coefficient of x, that's 3, close bracket squared, and I subtract the 3 squared, close bracket, and it's plus 7. So that's going to be minus, and I'm multiplying the minus 1 into the bracket, so it's minus of x plus 3 squared, and minus times, this is minus 9, becomes plus 9, and it's plus the 7 that was already outside, so it's minus of x plus 3 squared, and 9 plus 7 is 16, and we can express it in the form they wanted it to be in, starting with the 16, so it's 16 minus of x plus 3 squared, and this here is the answer. Let's have another example. Here it says the function f is defined by f of x is equal to 7 minus 2x squared minus 12x for values of x that are elements of real numbers. So express 7 minus 2x squared minus 12x in the form a minus 2 of x plus b squared, where a and b are constants. So here we are saying for 7 minus 2x squared minus 12x, we are going to rearrange, so that is minus 2x squared minus 12x plus 7, and considering these two terms, I'll factor out the minus 2, okay, because we want the coefficient of x squared inside the bracket to be 1. So factoring out minus 2, we'll be having x squared, and here we'll be having plus 6x. Okay, so it's as good as we are dividing minus 12x by minus 2, and that's what gives us 6x, and we have the plus 7 right here. So basically now, if we complete the square, we'll be having, opening up the bracket, x here, and plus half of the coefficient of x, that's half of 6, which is 3, close bracket squared, and it's minus the 3 squared, and it's plus 7. The 7 is outside, so I close here, which will give us minus 2 of x plus 3 squared, and minus 2 times minus 9 will give us plus 18, and it's plus 7, and we'll be having minus 2 of x plus 3 squared, and 18 plus 7 is 25. So rearranging, we'll be having 25 minus 2 of x plus 3 squared, and this here will be the answer. So that's how we do it right here. Now the last completed square form we want to look at is the form ax plus b all squared plus c. And I have a few particular questions where we have to express the completed square form in that form. Okay, so we want to start with this one where they say we should express 9x squared minus 12x plus 5 in the form ax plus b squared plus c. So here we have 9x squared minus 12x plus 5, and to complete the square, I'll start by factoring out the 9. So 9, open bracket, then I'll be having x squared here. And next, I'm going to divide minus 12x by 9, and that's going to be minus 12 over 9 x, close bracket, and it's plus 5. So basically, that's 9 of x squared minus 4 over 3 of x, and it's plus 5. So we're going to complete the square now, where we'll be having here x, and half of the coefficient of x will be half of minus 4 over 3, which is minus 2 over 3, close bracket squared, and we subtract the minus 2/3 squared, and close bracket, and it's plus 5. This will give us 9 of x minus 2/3 squared, and here that will be minus of 2 squared, that's 4, over 3 squared, that's 9, close bracket, and it's plus 5. Now I'm multiplying 9 into the bracket, into the square bracket, so that we'll be having 9 of x minus 2/3 squared, and 9 times minus 4 over 9 is minus 4, and there's a plus 5 here. All right. Okay, so looking at this and what they want us to have, we do not have a constant outside the bracket, but the constant a is multiplying x inside the bracket. So what we do here is we're going to express 9 as a square, so it's as good as 3 squared, and it's x minus 2/3 squared, and minus 4 plus 5 is actually 1, and this is as good as 3 of x minus 2/3 close bracket all squared, okay, plus 1. So we can multiply now 3 into the bracket, so that we'll be having 3 times x, that's 3x, and 3 times minus 2/3 is minus 2, close bracket squared, and plus 1, and we now have the answer in the form they want it to be in, and that's how we do it. Okay, let's have another example. And here it says express 16x squared minus 24x plus 10 in the form 4x plus a squared plus b. All right, so we have 16x squared minus 24x plus 10. I'll factor out the 16 for the first two terms, so we'll be having x squared minus and 24x divided by 16, that will be 3 over 2. So basically 3 over 2 of x, close bracket, and it's plus 10. So here we have not yet started completing the square, but we're now going to complete the square on this step. Open bracket, x minus half of the coefficient of x would be half of this 3/4, close bracket squared, and we subtract the minus 3/4 squared, okay, and it's close bracket, and we have a plus 10 here. All right, so it's 16 of x minus 3/4 squared and minus of 9 over 16 here, and it's plus 10 on the outside. Okay, so I'm now multiplying 16 into the square bracket, so it's 16 of x minus 3/4 squared. All right, and 16 times this will be minus 9, and it's plus 10. Now I'm going to express 16 as a square, so it's like 4 squared of x minus 3 over 4 squared, and minus 9 plus 10 is 1, so it's plus 1 right here. All right, and we're going to say this is the same as 4 of x minus 3/4 close bracket, but everything is squared, and it's plus 1. Now we're multiplying 4 into the bracket, so it will simply be 4x, and 4 times minus 3/4 is minus 3, close bracket squared, and it's plus 1. And that's the form they want the answer to be in, and that's how we do it basically. All right, so that's it for completing the square. So let's move on to the concept of the quadratic curve. Now you need to understand that curves with equation y is equal to ax squared plus bx plus c, where a, b, and c are constants, are called quadratic curves, and they have a characteristic shape which we call a parabola. So the curves will come in two forms. The first curve is for quadratic equations where a, the coefficient of x squared, is less than 0, that is, it's negative. So for such a case, the quadratic curve will have a shape like this one with a maximum turning point. Then if a is greater than 0, that is, if the coefficient of x squared is positive, then the curve will have this shape, which is a smiley face shape, and the graph will have a minimum turning point. Now when sketching a quadratic curve, you have to be able to find the coordinates of the turning point, which we also call the vertex of the quadratic curve. And there are two methods that we can do that. The first method of finding the vertex or the turning point would be to use the concept that if you have y is equal to ax squared plus bx plus c, then the x coordinate of the turning point is x is equal to minus b over 2a. And once you've gotten the x coordinate, you can then find the y coordinate by substituting that x value into the equation of the curve. So let's look at this example. It says, find the coordinates of the minimum point of the curve y is equal to 9 over 4x squared minus 12x plus 18. Alright, so this is a curve that has a minimum point, which is a turning point. And to find that, we are using the fact that the x coordinate can be found by minus b over 2a. And in this particular case, a is the coefficient of x squared, that's 9 over 4. B is the coefficient of x, that's minus 12. And c is the constant, which is 18. Alright, so therefore, x will be minus b, which is minus of minus 12. And that's divided by 2 of a, which is 9 over 4, like this. So basically, we have minus of minus 12, which is 12, and divided by, this is 2 times 9 over 4 is 9 over 2. So dividing by 9 over 2 is like multiplying by 2 over 9. And this will give us, here 3 goes in 3 times and 3 goes in 4 times. So we get 8 over 3 as the x coordinate of the turning point. Now, to get the y coordinate, we use the equation. So it will be y is equal to 9 over 4 of x squared, which is 8 over 3 squared, minus 12 of 8 over 3, and it's plus 18. So I'm going to use my calculator here. So I'll have 8 over 3 stored into x. So it's here 9 over 4 x squared. So 9 over 4, and that's of x squared, and it's minus 12x plus 18, and we get 2. So the y coordinate is 2. So therefore, the minimum point is x coordinate 8 over 3, y coordinate 2, and this here is the answer. So this is basically how we can use the fact that x is equal to minus b over 2a to find the coordinates of the turning point or vertex of a quadratic curve. Now the second method is the method of completing the square. If you have been given the equation of a quadratic curve in completed square form, p of x plus q squared plus r, then the coordinates of the turning point of the curve will be minus q and r. Okay, so let's have an example. And here is the question. It says, express 2x squared minus 10x plus 8 in the form a of x plus b squared plus c, where a, b, and c are constants, and use your answer to state the minimum value of 2x squared minus 10x plus 8. Alright, so we do the first thing that they've asked. We have 2x squared minus 10x plus 8, and we factor out the 2 for the first two terms, which will be x squared minus 5x in here, and the plus 8. Then the 2, here we complete the square, so it's x plus half of the coefficient of x, which is minus 5 over 2, close bracket squared, and we subtract the minus 5 over 2 squared, close bracket, and it's plus 8. Next, we have 2 of x minus 5 over 2 squared, and that's minus 25 over 4, close bracket, and it's plus 8. Now we're multiplying 2 into the bracket, so that will be 2 of x minus 5 over 2 squared, and it's minus 25 over 2 after multiplying 2 by this, and it's plus 8. All right, so finally we'll be having 2 of x minus 5 over 2 close bracket squared, and minus 25 over 2 plus 8 is minus 9 over 2. So therefore, they say use your answer to state the minimum point. Okay, so the minimum point will be minus q and r, which is minus of minus 5 over 2, which is 5 over 2, and the term outside minus 9 over 2. So this is how we find the minimum point. Okay, so this is the minimum value as they want, and that's how we do it. One more example. Here they say the function f is defined by f of x is equal to 4x squared minus 24x plus 11 for values of x that are elements of all real numbers. Express f of x in the form a of x minus b squared plus c, and hence state the coordinates of the vertex of the graph of y is equal to f of x. All right, so we have the 4x squared minus 24x plus 11, and they want us to complete the square basically. So factoring out the 4, we get x squared minus 6x inside the bracket, and it's plus 11. 4, now completing the square, of x minus 3 squared minus 3 squared close bracket plus 11. 4 of x minus 3 squared, and this is minus 9 plus 11. Now I'm applying 4 into the bracket, so it's 4 of x minus 3 squared minus 4 times 9, 36, and it's plus 11. All right, so that's 4 of x minus 3 squared, and minus 36 plus 11 should give us minus 25, right? So minus 25. So this is what we have after completing the square. And now they say hence state the coordinates of the vertex of the graph, which is the turning point. So we will be having minus of whichever term is here. So it's minus of minus 3, which is 3, and the term outside minus 25. So this will give us the coordinates of the vertex of the graph. So that's how we do it right here. Now we want to look at how we can sketch the quadratic curve itself. So there's a question which would require us to make a sketch, which is this question you can see on the screen right now. It says the equation of a curve is y is equal to 4x squared plus 20x plus 6. On part A, express the equation in the form y is equal to a of x plus b squared plus c, where a, b, and c are constants. Right. So let's start with that first part, part A. We have 4x squared plus 20x plus 6. If we complete the square as they want it to be, it will be 4 of x squared plus 5x, close bracket, and the plus 6 is outside. Now we complete the square, so it's 4 of open bracket x plus half coefficient of x, that's 5 over 2, close bracket squared, and it's minus the 5 over 2 squared, close bracket, and it's plus 6. So 4 of x plus 5 over 2, close bracket squared, and it's minus, here that will be 25 over 4, close bracket, plus 6. Now multiplying 4 into the bracket, we'll be having x plus 5 over 2, close bracket squared, sorry, there's a 4 here, and it's minus 4 times this, that will be minus 25, and it's plus 6. Okay, so we have 4 of x plus 5 over 2, close bracket squared, and it's minus 25 plus 6 is minus 19. So this is what we have. So this is y, like this, as they want. Let's go on to part B. Now, on part B, they say, hence solve the equation, this is equal to 45. All right, so we're saying 4x squared plus 20x plus 6 being equal to 45. It's as good as 4 of x plus 5 over 2 squared, and it's minus 19 being equal to 45. Here we are going to take the minus 19 to the right side. So we have 4 of x plus 5 over 2 squared being equal to 45 plus 19, which is 64. So we have 64 here. Dividing both sides by 4, we'll be having x plus 5 over 2 squared is equal to 64 divided by 4, which is 16. From here, we are going to square root both sides. And if we do, we'll be having on the left side x plus 5 over 2. And it's equal to plus or minus 4. All right. So like this, which would mean that x is equal to minus 5 over 2 plus or minus 4. All right. So the possible answers are minus 5 over 2 minus 4, or minus 5 over 2 plus 4. All right. So the values of x will be minus 5 over 2 minus 4 should give us minus 6.5, because this is minus 2.5 minus 4. So minus 6.5, which is like minus 13 over 2. And the other one, minus 5 over 2 plus 4, should give us 1.5, which is 3 over 2. So these are the possible answers of x. That's how we solve the equation right there. On part C, they say, sketch the graph showing the coordinates of the stationary point. Okay, sketching. They also say you are not required to indicate where the curve crosses the x and y axis. All right. Okay, so the curve we want to sketch is this curve here. So I'll copy this and I'll scroll down, and we are on part C, by the way, part C. So the equation of the curve is this one here. And what information can we find? We can find the turning point. And the turning point, since we had completed the square above, we'll take minus of 5 over 2 and the term outside. So it's minus 5 over 2 and minus 19. So here, that's minus 5 over 2 and minus 19. Now also, we can see that the coefficient of x squared is greater than 0, is positive, which means that we know that our graph is going to be smiley face. So this information is enough to give us an idea of how the graph is like, right? So I have the two axes, and considering the position of the turning point is in this quadrant here, okay, minus 5 over 2 and minus 19. So the graph should be more like this. I would say the graph is like this, okay, where the turning point is at minus 5 over 2 and minus 19, and it intercepts the y-axis. That's when x is equal to 0. When x is 0, y is 6, like this. So this is how the graph should be like. All right, and that's how we do it. Now let's talk about quadratic inequalities. Right, so let's consider a quadratic function f of x, which is represented by this graph here. Now let's say that a and b are the roots of f of x equal to 0. So that basically means that the graph intercepts the x-axis at a and at b. But now, let's say we are required to solve the inequality f of x is greater than 0. then we'll be considering values of x that are such that the curve is greater than 0, or in other words, above the x-axis. So which values of x are those? It certainly should be values of x that are less than a and values of x that are greater than b. These are the values that satisfy the equation f of x is greater than 0. We're saying that these are the set of values of x where the graph is above the x-axis. So this will be the solution set. Now, if we were rather asked to solve the equation f of x is less than 0, we would be considering the set of x values for which the graph is below the x-axis. So values of x between a and b are values that are such that the graph is below the x-axis. So values of x between a and b are represented by the inequality a less than x and x less than b. So this will be the solution satisfying this inequality. In a situation where we have the quadratic curve in this shape, where the roots are a and b, if you're asked to solve the inequality f of x is greater than 0, remember we said f of x greater than 0 means the graph is above the x-axis. So it's above the x-axis for values that are between a and b in this case. So the solution will be a to b. But for f of x is less than 0, we say the graph is below the x-axis for values of x that are less than a and values of x that are greater than b. That's where the graph is below the x-axis. So the solution set will be this. Let's see how we can apply this knowledge in solving some problems. The question here says, solve the inequality x squared minus x minus 2 is greater than 0. Alright. So in this particular situation, we have x squared minus x minus 2 being greater than 0. I'm going to factorize. And when we do, we'll be having x here and x, and factors of minus 2 will be 1 and 2. And here we'll be having a minus and a plus here. And I think it's all good. All right. Now, from here, you find what we call critical values, which are basically the roots when x plus 1 of x minus 2 is equal to 0. So we know that the possible values of x will be minus 1 or 2. All right. So these are the critical values. So if we make the graph or sketch of the quadratic curve, it should be like this, where the critical value minus 1 will be here and the second one, the 2, will be here. So we have the x-axis here. So we are now asking ourselves for which values of x is the graph greater than 0, that is above the x-axis. So that should certainly be values of x that are less, okay, x is less than minus 1, and values of x that are greater than 2. So union x is greater than 2. So this is the solution for this particular question. Let's look at the next question. On here, part 1, it says express 4x squared minus 12x in the form 2x plus a squared plus b. Okay, let's do part 1. This is simply completing the square. So 4x squared minus 12x equals to 4 of x squared minus 3x. I've just figured out the 4. Then 4, now completing the square, of x minus 3 over 2 squared minus 3 over 2 squared, like this. So that will be 4 of x minus 3 over 2 squared, and that's minus 9 over 4. And now multiplying 4 into the bracket, that will be 4 of x minus 3 over 2 squared minus 9. Okay, so this is what we are getting. Now here they're saying it has to be in this form. We need to have a 2x inside the bracket. So we know that 4 is 2 squared. Okay, and it's x minus 3 over 2 squared minus 9. So we can take the 2 into the bracket, so it's like 2 of x minus 3 over 2 squared. Okay, the squared has to be outside, minus 9, and multiplying 2 inside, we will eventually be having 2x minus 2 times minus 3 over 2, that's minus 3, close bracket, squared, minus 9. And we now have the answer to part 1 right here. Now, going on to part 2, they say, hence or otherwise, find the set of values of x satisfying this inequality. Okay, so we have the inequality 4x squared minus 12x is greater than 7. Now, since they're saying hence, it means we can use the results we got right above. And we had gotten 4x squared minus 12x to be this. So we can substitute that, which means that it's as good as we have 2x minus 3 squared minus 9 being greater than 7. Alright, so I'll take the 7 to the left, which means that we'll be having 2x minus 3 squared, and minus 9 minus 7 is minus 16, and is now greater than 0. So this is as good as we have 2x minus 3 squared, and minus 16 is like minus 4 squared is greater than 0. So this is like a difference of 2 squares, where we can say that this is as good as 2x minus 3 minus 4 of 2x minus 3 plus 4. Okay, and it's greater than 0. So I've used the difference of 2 squares. Remember, a squared minus b squared can be factorized into a plus b of a minus b. So that's basically what I've done here. So that's gonna give us 2x minus 7 and 2x plus 1, and it's greater than 0. So from here we can find the critical values, and for the critical values we'll simply say 2x minus 7 of 2x plus 1 equal to 0, and we solve for x, so x comes out as 7 over 2, or x is minus a half. Okay, so essentially here we will be having the curve like this. Here's the x-axis, and it's going to be a U-shaped parabola. So we know that it is going to be like this, and it intercepts the x-axis at 2 points, the critical values, minus a half and 7 over 2. Now, greater than 0 means above the x-axis, and is for values of x that are less than minus a half, and values of x that are greater than 7 over 2, that the graph is positive, or that the graph is above the x-axis. So this here is the solution. So that's how we do it right here. Let's have one more example. And here is the question. It says the function f is defined by f of x is equal to x squared minus 4x plus 8 for values of x that are elements of all real numbers. So on part 1, express x squared minus 4x plus 8 in the form x minus a squared plus b. Alright, so let's start with that part 1. Okay, they say we have x squared minus 4x plus 8, and they want it to be in this form, so we're basically completing the square. So we'll be having x minus 2 squared minus 2 squared plus 8, and this will be equal to x minus 2, and that's minus 4 plus 8, which is just 4. So we have it like this. Now on part 2, they say hence find the set of values of x for which f of x is less than 9, giving your answer in exact form. Right, so here we're saying for f of x is less than 9, this is like saying x minus 2 squared plus 4 is less than 9, and I'll take the 9 to the left, so it's basically x minus 2 squared, and 4 minus 9 is minus 5, and it's less than 0. Now from here, like we did in the previous example, we will consider this to be a difference of two squares, so it's basically x minus 2 squared minus 5 is as good as root 5 squared. It's less than 0. Okay, so since it's now a difference of two squares, we can write it as x minus 2 minus root 5 of x minus 2 plus root 5 is less than 0, which would mean that for the critical values, we can simply say that x minus 2 minus root 5 of x minus 2 plus root 5 is equal to 0, and the particular values of x we will get here are 2 plus root 5 and 2 minus root 5. So this is what we will be having. Okay, now we can solve using the graph. So I'll make a sketch of the quadratic curve, and the x-axis is here, and the curve is a U-shaped parabola, so like this, and we have the smaller value being the 2 minus root 5, and the bigger value being the 2 plus root 5. Okay, and less than 0 means values that are below the x-axis, and these are values of x that are between 2 minus root 5 and 2 plus root 5. So therefore, the solution is 2 minus root 5 to 2 plus root 5. So this is the solution right here. And that's how we do it right here. Now we're moving on to the concept of nature of quadratic roots, where we're going to be talking about the discriminant. Now it's important for you to know that the nature of the roots of a quadratic equation can be determined by the discriminant. And what is the discriminant, you may ask? All right, so we're saying for ax squared plus bx plus c equal to 0, b squared minus 4ac is the discriminant. So this discriminant helps us to determine the nature of the roots. So if b squared minus 4ac is greater than 0, it means we have distinct real roots. If b squared minus 4ac is equal to 0, it means we have repeated real roots. And if b squared minus 4ac is less than 0, then we have imaginary roots or no real roots. Okay. All right, so let's just look at a question which involves the discriminant. And here it is. It says, find the set of values of k for which the equation 2x squared plus 3kx plus k equal to 0 has distinct real roots. All right, so for this particular case, we know that if we have distinct real roots, then the discriminant should be greater than 0. In this particular case, a is the coefficient of x squared, and that's 2. B is the coefficient of x, and that's 3k. And c is the constant term, which is k. So b squared minus 4ac should be greater than 0 if we have distinct real roots, which means that 3k squared minus 4 of 2 of k should be greater than 0. So 9k squared minus 8k is greater than 0. And if we factor out k, that will be 9k minus 8 is greater than 0. And the critical values here will be k is equal to 0 or k is equal to 8 over 9. Okay, remember, we get the critical values by equating this to 0. So with this, we can go straight on to the quadratic curve. And we know that the graph is a U-shaped parabola again. because the coefficient of k squared is positive and the lower value here is a 0 and the bigger value is an 8 over 9. Okay, so like this. And greater than 0 means above the x-axis, and it's above the x-axis for values of k that are less than 0 and values of k that are greater than 8 over 9. So this here is the answer. Let's go on to the next question. Here they say, find the set of values of k for which the equation 8x squared plus kx plus 2 equal to 0 has no real roots. Okay, so in this case, A is 8, B is k, and C is 2. No real roots means b squared minus 4ac is less than 0. So that's k squared minus 4 of 8 of 2 is less than 0. So k squared minus 64 is less than 0. So that's k, that's a difference of 2 squares. So it's k minus 8 of k plus 8 is less than 0. And the critical values, by equating this to 0, we get k to be plus or minus 8. So if we go to the quadratic curve to determine the solution, we'll be having something like this, and we have this to be k, and this to be minus 8, and this to be 8, and less than 0 means negative, the values that are below the x-axis, which are values of k between minus 8 and positive 8, and this is the solution right here. That's how we do it. Now it's important for you to know that the discriminant can be used to determine how a line intersects with a curve. So in the same way, if b squared minus 4ac is equal to 0, then the line will touch the curve once. So in other words, the line is a tangent to the curve. And if b squared minus 4ac is greater than 0, it means that the line touches the curve twice. But if b squared minus 4ac is less than 0, it means that the line and the curve do not meet at all. Let's look at this particular question here. It says, a line has equation y is equal to 2cx plus 3, and a curve has equation y is equal to cx squared plus 3x minus c, where c is a constant. Showing all necessary working, determine which of the following statements is correct. So we have three statements. A says that the line and the curve intersect only for a particular set of values of c. On B, the line and the curve intersect for all values of c. And on C, the line and the curve do not intersect for any values of c. Alright. Okay, so we have two equations here representing a line and a curve. And we're going to equate these two equations since they are both in the form y is equal to something. So we can say here that cx squared plus 3x minus c is equal to 2cx plus 3. Taking everything to one side, we'll be having cx squared plus 3x minus 2cx, and that's minus c minus 3 equal to 0. All right. Now we'll be having cx squared, and on these two terms, I'll factor out x. So it's going to be plus 3 minus 2c of x, and it's minus of c plus 3 equal to 0. Okay. So we now have a quadratic where a is c, b is 3 minus 2c, and c is minus of c plus 3. All right. So here, what we're going to do is we're going to do the discriminant b squared minus 4ac, which will give us 3 minus 2c squared minus 4 of c of minus c plus 3. So this will become a plus. So c plus 3 here. That's 9 minus 12c plus 4c squared plus 4c squared plus 12c, expanding the brackets. Rearranging 4c squared plus 4c squared is 8c squared, and minus 12c plus 12c is 0, then plus 9. So we have 8c squared plus 9. Okay. Now the discriminant is giving us this. And I think you can see that for any value that c can take, the discriminant, the 8c squared plus 9, will always be positive. It will always be greater than 0 for all possible values of c. And greater than 0 for the discriminant means two distinct real roots. So from the options we have, on A that said the line and the curve intersect only for a particular set of values of c, which would be wrong. Okay, we say that for all values of c, the line and the curve will intersect. B says the line and the curve intersect for all values of c, which is correct. Then C says the line and the curve do not intersect, which is wrong. They do intersect because b squared minus 4ac is greater than 0, so they should intersect. So the correct answer is B. Alright, that the line and the curve will intersect for all possible values of c. So that's how we handle a question like this one here. Let's have one more. And here it is. It says, a curve has equation y is equal to kx squared plus 1, and a line has equation y is equal to kx, where k is a non-zero constant. So on part 1, find the set of values of k for which the curve and the line have no common points. Okay, so that's part 1. Alright, so here the line and the curve have no common points, which means that the discriminant should be less than 0. Right, so we start by combining the two equations, equating them, since they are all in terms of y, in terms of something. So kx squared plus 1 is equal to kx. Take everything to one side. Kx squared minus kx plus 1 equal to 0. A is k, b is minus k, c is 1. So b squared minus 4ac should be less than 0 because they do not intersect. Alright, they have no common points. So that's basically minus k squared, and it's minus 4 of k of 1. It's less than 0. So that's k squared minus 4k is less than 0. So it's like k of k minus 4 is less than 0. And the critical values will be k equal to 0 or k is equal to 4. And if we consider the graph, we'll be having here 0 and here a 4. And less than 0 means values between 0 and 4. So the solution here will be values of k between 0 and 4. Now on part 2, the question says, state the value of k for which the line is a tangent to the curve, and for this case, find the coordinates of the point where the line touches the curve. Okay, so on part 2, we're talking about the tangent. That's part 2. And tangent means b squared minus 4ac equal to 0. Now, the discriminant b squared minus 4ac, we had gotten it and simplified it to k of k minus 4. So we can just take that, k of k minus 4 equal to 0. And we know from here that k should have a value of 0 or k should have a value of 4. But for these two values of k, we had been told that k is a non-zero constant, which means we cannot take this value of k. K cannot be equal to 0. So rather, we'll take that k is equal to 4. And when k has a value of 4, therefore, we're saying if k is 4, then we can substitute k into the equation. Let's take this combined equation. So I'm just going to copy this and paste it down here. We can substitute 4 here, which means we'll be having 4x squared minus 4x plus 1, and we are equating that to 0. So this is all equal to 0. Remember, we're trying to answer the part that said, for this case, find the coordinates of the point where the line touches the curve. So this is all equal to 0. Okay, and this apparently is a perfect square, so it's like 2x minus 1 squared if you factorize it, equal to 0, where we get the values of x to be a half, and the corresponding value of y when x is a half, y will be, remember, one of the equations was y is equal to kx, so it will be y is equal to k, which is 4, of x, which is half, so y is equal to 2. So therefore, the point of intersection will be half and 2, and this here will be the answer. And that's how we do it. So now we are moving on to disguised or hidden quadratic equations. So these are quadratic equations that do not seem to be quadratic, and yet they can be modeled or expressed in a quadratic form. An example is this one here. It says, by using a suitable substitution, solve the equation, and that's the equation given. I'll say here, let y be equal to 2x minus 3 squared, which therefore means that this equation is as good as y minus 4 over y minus 3 equal to 0. So I am going to multiply each one of the terms by y. So by y here, by y here, by y here, and by y here. And this will give us y squared minus 4 minus 3y is equal to 0. Rearranging, that's y squared minus 3y minus 4 equal to 0. Factorizing, we should get y and y here minus 4 and plus 1, and it's either y minus 4 that's equal to 0 or y plus 1 that's equal to 0. So y is 4 and y is equal to minus 1. Okay, so these are the two possible values of y. All right, now from these two values of y, remember we had said that y is this because we're solving for x, so we can say that therefore 4 is equal to 2x minus 3 squared. But for the y is equal to minus 1, it will give us no solution. Okay, this will give us no solution because y is negative, because at some point we shall need to square root both sides and we'll get no real solution from square rooting a negative number. So we'll just work with this. If we square root both sides, we'll be having plus or minus 2 is equal to 2x minus 3. And if we make x the subject, we'll be having 3 plus or minus 2 or over 2. So the values of x are 3 minus 2 over 2 or 3 plus 2 over 2. So the values of x are a half or 5 over 2. So these are the two solutions right here, and that's how we do it. We want to go on to another example. I want you to look at this one here. Solve the equation given. I'll say here, let u be equal to the square root of y. And here, that would therefore be 6u plus 2 over u minus 7 equal to 0. And from here, I'm going to multiply all the terms by u. So by u here, by u, by u, by u. And we will get right here 6u squared plus 2, because the u's will cancel, and it's minus 7u is equal to 0. And rearranging, that's 6u squared minus 7u plus 2 equal to 0. Now, from here, what we're going to do is we are going to factorize, all right? So if we factorize, I'll be having 2 brackets. And for 6u squared, I'll use 3u and 2u. And here, I will have 2 and 1, minus and minus, and we've factorized it. So therefore, the possible values of u will be, equating this to 0, we get u to be 2/3, and equating this to 0, we get u to be a half. So we are therefore saying that since u is root y, so 2/3 should therefore be equal to the square root of y, and a half should be equal to the square root of y. Squaring both sides, we get y to be 4/9, and here y to be a half squared, which is a quarter. So these two are the possible solutions right here. Let's have one more hidden or disguised quadratic equation, which is this question here. It says, solve the equation 8x to the 6 plus 215x to the 3 minus 27 equal to 0. Okay, so right here, we have this equation, and we have to make it quadratic by saying let's say y be equal to x cubed, and the equation here can be represented as 8 of x cubed squared plus 215 of x cubed minus 27 equal to 0. So if we put y in place of x cubed, that will be 8y squared plus 215y minus 27 equal to 0. All right. Now, we have to factorize this. And to factorize this, okay, if you do your factorization, okay, you should be getting 8u here and u and minus 1 here and plus 27. And this is how you factorize it. This is what you get when you factorize it. And the possible values of u then will be an eighth or minus 27. So since we had said that y is equal to x cubed, then an eighth should be equal to x cubed. And if we cube root both sides, okay, if we cube root both sides, we'll be having the cube root of 1/8 equals to the cube root of x cubed. We will get x coming out as a half here, and minus 27 is also equal to x cubed. And if we cube root both sides, we will get minus 3 here being the value of x. So we are saying that the possible solutions are x is equal to a half, and or let's just say and x is equal to minus 3. And that's how we do it for this particular question. We're moving on to the very last thing, which is simultaneous quadratic equations. And we're just going to look at questions which involve simultaneous equations from past papers. So we are going to start with this particular question here. It says, the diagram shows the curve y squared is equal to 2x minus 1 and the straight line 3y is equal to 2x minus 1. The curve and the straight line intersect at x equals to a half and x is equal to a, where a is a constant. Show that a is equal to 5. All right. So we have two equations here. Y squared is equal to 2x minus 1 and 3y is equal to 2x minus 1. So in order for us to find what they want us to find, we have to solve these two equations simultaneously. And the best way to do it is through substitution, okay? Or another way would be to consider that from this first equation, we can make 2x the subject to be y squared plus 1, and here we can make 2x the subject to be 3y plus 1. And therefore, since these are all 2x's, we can therefore say y squared plus 1 is equal to 3y plus 1. And rearranging, we'll be having y squared minus 3y, and 1 minus 1 is 0, so this is equal to 0. Okay, so y of y minus 3 is equal to 0, and the possible values of y will be y is equal to 0 or 3. All right, now when we have these two values of y, we also need to find the corresponding values of x. All right, so let's have a small table here to put in the values. Okay, so we're saying here we have x and we have y. The values of y are 0 and 3, and for the corresponding values of x, we're saying when y is 0, look at this equation. When y is 0, this will become 0, so 0 is equal to x minus 1, so we will get x to be a half. And we already have that value. Okay, x is a half, so this point is given. The one they want is a, all right, which is the other x value. So that's when y has a value of 3, and when y has a value of 3 here, okay, so we're saying when y is equal to 3, then 3 of 3, I'm using the second equation, will be equal to 2x minus 1, which is 9, is equal to 2x minus 1, which is 10, is equal to 2x. Therefore, x is equal to 5. So we are saying that a is 5. That's the x value, and that's the answer right here. Let's go on to the very last question here, which is this one here. And they say the diagram shows parts of the curves y is equal to 9 minus x cubed and y is equal to 8 over x cubed, and their points of intersection P and Q. The x coordinates of P and Q are A and B respectively. Show that x is equal to A and x equals to B are roots of the equation x to the 6 minus 9x cubed plus 8 equal to 0. Solve this equation and hence state the value of A and the value of B. Okay, so again here we have simultaneous equations, and this time it's just by equating the two. We are equating 9 minus x cubed to 8 over x cubed. All right, so from here what I'm going to do is I am going to multiply both sides by x cubed and this side again by x cubed, so that we'll be having x cubed multiplying 9 minus x cubed, and here these will cancel and we have an 8. So 9x cubed minus x to the 6 is equal to 8. And rearranging, we'll be having x to the 6 minus 9x cubed plus 8 equal to 0. So now the equation is in this form. All right. Now they want us to find the values of a and b. Okay. So for the values of a and b, we are solving this equation, right? A and b are x values. So we are solving for x. So I'll say let u be equal to x cubed, which therefore means that this equation will be u squared minus 9u plus 8 equal to 0. So basically, if we factorize, okay, we have an 8 here. So let's use 8 and 1 and minus and we'll be good. So we can get that the values of u are 1 or 8. And if we take back the substitution, where u is x cubed, we can therefore say that 1 is x cubed, leading to x being equal to the cube root of 1, which is 1, and 8 is equal to x cubed, leading to x being equal to the cube root of 8, which is 2. So x is 1 or x is 2. Right, so for the values of a and b, The smaller one is A and the bigger one is B. So for these two x values, we can therefore say that A is 1 and B is the bigger one, so B is 2. And these two are the solutions. And that's essentially how we do it.